Alright, so let's say given this diagram here, and the question says, consider the two particle system above. If momentum A is 5 kilograms times meters per second, and momentum B is 6 kilograms times meters per second, find the total momentum P for the system. To start, to find the solution, we must first know the conservation of momentum. So let's consider a two particle system given below, where they both exert a force on each other, noted by FB on A, which is the force the B particle exerts on A, and then FA on B, which is the force that A exerts on B. The forces that particles A and B exert on each other are internal forces. This means that these forces are created by the particles themselves, not by an outside source. By Newton's third law, we can write that the force B particle exerts on A is equal to the negative of the force A exerts on B. This basically just means that the forces they exert on each other are always equal and opposite in magnitude. We also know from Newton's second law that force is equal to the change in momentum over change in time. So the forces they exert on each other can be written in this form here, where the force B exerts on A is going to be equal to the change in the momentum of the A particle. And we can write a similar expression for the B particle like so. From this equation above, we can bring the right term to the left side, and we get that sum of the total forces is going to be equal to 0. If we plug in our new definitions for the forces in terms of momentums, we can see that the sum of the forces is equal to the sum of the change in momentums is equal to 0. We can define the total momentum of the system of the two particles as the sum of the momenta. Total momentums is going to be equal to the sum of the particles' momentums. Using this definition, we can find this equation here. This means that the time rate of change of the total momentum is 0. And what does this mean? This is the fundamental conservation of momentum equation. If the vector sum of external forces is 0, i.e. only internal forces are present. So we can see on the left-hand side here, the only forces are the internal forces. If there was an external force, there would be an extra term here. But if there's only internal force, the total momentum is conserved, which means that the change in momentum is equal to 0 because the momentum doesn't change. So we can apply this to our example. This is our example here, and we know that the total momentum is equal to the summation. The first thing to note is that these are vector quantities, so we need to add them by the component method. We can identify that the momentum of particle A is 5 kilograms times meters per second up, and then the momentum of particle B is 6 kilograms times meters per second to the right. If we plug these two values in, how do we find the answer from this? We can use the Pythagorean theorem. This is our situation here. We also have to note that since P is a vector quantity, we need a magnitude and direction. So if we start with the magnitude, we can use the Pythagorean theorem like so. If we plug in our momentums PA and PB, we can start by computing the squares of both terms, and then we can do a simple summation of the expression under the square root, and then we can just square root the expression and get the answer for the total momentum of the system. And so what is theta? This is our system here. We can use the trig identity tan theta is equal to opposite over adjacent. Opposite is going to be this value here because it's opposite to theta, and then adjacent is going to be this value here because it's adjacent to theta. So the units are going to cancel, and then we can find the angle by taking the tan inverse, and if we do that, we find the angle is equal to 51 degrees. The final answer is going to be equal to 7.81 kilograms times meter per second. Then it's going to be 61 degrees with respect to the vertical. As we can see, theta is this angle here. It's 51 degrees with respect to the vertical, like we said.